minimum value of a of a trigonometric expression, a trigonometric quotient, I guess. And it turns out we can split it apart in a way that takes advantage of something called the AIME inequality. And everybody's familiar with the average of two numbers. That's called the arithmetic mean. And it can be shown that the arithmetic mean is always greater than or equal to, they call the geometric mean, which is the square root of the product. So this is a pretty fundamental inequality in that it relates addition and multiplication. All right, now you may be wondering, this isn't what we're interested in for this problem today, but equality would occur when A is equal to B. When A is equal to B, equality occurs. And a simple example would be, just think of 6 plus 6 over 2. Just 6 plus 6 over 2, okay, is certainly equal to the square root of 6 times 6, right? So it's pretty easy to see why equality occurs when the two inputs are equal to each other. Okay. Now again, we're not looking for that today. We're just looking for the minimum value. Okay. So the rest of this is just very straightforward. It's just an immediate application of this right here. You see, you got, this is definitely in the form. This part here lines up with this. This part here lines up with this, and you can see that it's very nice that these two terms, root x, cosine x, is going to cancel out nicely here. Now, it should probably be mentioned that it's assumed that A and B are greater than 0, I believe, probably greater than or equal to 0. Greater than or equal to 0. And the trig function doesn't care. There's times where that trig function is going to be negative, but this is still going to get you to the minimum value. Okay, so the rest of it is very, very straightforward. You end up with this, 11 times 17 is 87. 187, excuse me. And y'all, just if you're interested in the value of this number, you know that 13 is less than the square root of 187. This is just for estimate purposes. We're done with the problem right now. This is the minimum value of this. But 13 is less than the square root of 187. Is less than 14, right? 13 squared is 169 and 14 squared is 196. So this inequality certainly holds. So this would give you an estimate. It would be 2 times the number between 13 and 14, or a number between 26 and 28. Now, if you're interested, when you equate these two objects, that would give you a way to find where this minimum value occurred. Now, if you equate these two objects, it looks like you're going to get 17x cosine squared x. Now, I don't even have any idea how to solve this one, but you could at least numerically figure out, that's what happens when you equate these two guys. If you multiply through by this, this is what you get when you equate this. And again, equality occurs when the two things are equal to each other. So this would have an infinite number of solutions, and I wouldn't even know how to begin to solve this. This looks nasty, probably just numerically. But you could find out the exact values where this object was getting its minimum value. But we'll call this the min, and we're done. Okay, that's the minimum value, and it happens an infinite number of times if you care about that. But that completes the problem. Hope you enjoyed.